Okay, so pooled OLS tries to correct the unobserved, tries to remove or eliminate the unobserved heterogeneity, by using serially correlated heteroscedastic standard errors. And we have seen different kinds of them. Another way to deal with the unobserved heterogeneity is by using something we call the phase difference. The phase difference. The phase difference, what it does is that it removes the UI, which can occur when the UI, the unobserved factor, the ability, is correlated with one of the independent variables, the x's. So in this case, when there is a covariance between UI and xit, when the covariation is not zero, so when there is a correlation between the UI and the xit, well, when this correlation is there, it means that there is an endogeneity. An endogeneity is when one of the independent variables is correlated not with another independent variables for us to have multicollinearity and deal with it. No, it is correlated with one of the elements of the error term, in this case, the unobserved factor. That's endogeneity. We'll look at endogeneity fully later on under two-stage least squares. Okay, I'll do the videos for you. So in such a case, then the OLS is going to be biased because there's a correlation between the UI and the xit. And when the OLS is biased, it's not only biased, but it's also inconsistent. You have to understand what we mean by biased and inconsistent. Biased means that the coefficient is not the same as the true coefficient. Remember, the beta cap is estimated because you don't observe the beta. And so you try to get closer to the beta. And that's why we estimate by OLS. And what we are saying is that when there's endogeneity, the OLS is biased. So the beta cap that you will even get is not the true beta, the unknown beta. And also, we also know that even if it's not closer to it's not the unknown beta, when you increase the sample size, okay, you are raising the asymptomatic nature of the sample size. What happens is that the beta cap converges towards the beta. The coefficient converges towards the true coefficient. And when that is so, we say it is consistent. It is best linear, unbiased estimator. It's efficient and consistent. And so if it is inconsistent, it means that it's not converging towards the true value. It's not converging towards the true value. So how does the phase difference eliminate the UI? Well, this is it. It removes all time invariant individual specific factors. I want to repeat that because this is the only thing that you need to understand here. What a phase difference does is that anything that doesn't change with time, anything that is fixed over time. You know, there are some factors that are fixed. I'm going to ask you some of them very soon. That are static over time. Such factors are removed by the phase difference approach. It does this by phase difference in the data, lagging the model, subtracting the lags, and then all the time fixed factors, the components, the time constant, the intercept and all individual components, all of them are eliminated. Now, who can tell me in this model which variables are time fixed? They are not changing with time. Who can tell me? Who can remember some of them? In this very data set, who can remember some of the variables that were not changing with time? Can you mention some of the variables to me that were not changing with time? Okay, can you type it or raise your hand and tell me? Variables that were not changing with time. Marital status. Marital status, we said it was changing with time because these children were between 17 to 23 years, and over the period, they will marry. That's what we said. Even though the pooled OLS we run right now didn't consider it that way. That is what we said. What else? Okay, variables that are constant. I say constant, I didn't say non-constant, constant. Ethnicity is one. In fact, ethnicity is key one, ethnicity. And then we also said that, and we are going to consider them now. Later, come and consider. We also said that education during that period of time, we do not expect the student to go and have another education because they just came out from the educational background and they have just entered the labor. We indicated and we mentioned that we consider education as fixed by the period. Okay, we'll come back to that. We'll come back to the intricacies of all of this. Okay, but for now, just understand race and ethnicity are the same. We mentioned those ones. So remember your panel model. This is your panel model that we've been dealing with all along. And in this panel model, how do you now eliminate the UI? Now watch, very soon you're going to see the UI vanish from here. How do you remove it? Well, first thing is that you take the lag for each section. So you YIT, you will subtract YIT minus 1 from YIT. And you will do that to any variable that has time in it. Any variable that has time in it, you now subtract its past value from it. So YIT has time in it, it will subtract. The epsilon IT has time in it, to subtract. XIT has time in it, to subtract. The lambda has time in it, so subtract. And the epsilon has time in it, so we'll subtract. Okay, we subtract that. But you can see that the UI has no time. Okay, so because the UI has no time, what do? We don't subtract time in it. And I made that point here. Okay. The UI has no time in it. And so we didn't even bring it. So when you do YIT minus YIT minus 1, you're going to get change in YIT. And that is this. As for this one, the epsilon, it will go. I mean, sorry, the alpha here will go. Okay. It will go because it's a constant value. The XIT will be a change in XIT. So everywhere there is a IT minus a YIT minus 1, you're going to have delta for it. You're going to have delta for it. Okay. And then this becomes the first difference model. Okay, so the answers most of you gave is here. How do you now get the fact of those variables that are constant over time? Education is constant over time, and we made those assumptions last time. We also said that the person's experience is changing deterministically by 1%, one year deterministically, okay? Because every year everybody's experience is changing. So we can say the experience is increasing, but at a constant rate. So we assume that it is constant. This was an assumption. And just a few minutes ago, somebody mentioned race or ethnicity. All of them are eliminated in the first difference. So remember, when we are going to do the modeling, we will eliminate those factors that are fixed over time in the original model. So this is original model. So what do you see? You can see that we have changes in the weight. We are just formulating it. And this is equal to changes in all of the factors that are changing with time. Those factors that are not changing with time, we have removed them. So you can see that there is no education here, but there is no education here. There's also no experience, but we have experience square. Now remember, why do we have experience square? Because that one is changing over time. Because we said that at some point the experience would diminish. So that's one we are including in. Union, we indicated the last time that a young person can move from joining a union to not joining a union. The person has the freedom to change. And we also indicate that over the time period, they can marry. So marriage will not be that constant. Okay, where a person will be single throughout the whole 8 years. These are young people. So they have the ability to. And of course, time dummies. Time dummies are already changing with time. So we still include those time dummies in there. And then we don't forget our unobserved heterogeneity. Sorry, don't forget our idiosyncratic noise. But you can see that the unobserved heterogeneity is removed. The whole essence of first difference approach is to remove this unobserved heterogeneity, which means that anything that is time constant gotta go. Your ability to formulate this into your journal paper. This modeling is important when you're modeling your work. So we will now have the opportunity to run that. That's the last thing you're going to do. Run the model by invoking the library PLM, if we haven't already done that. Then I'll use WFD for wage first difference. And then I will run the whole model. Now watch what I'm about to do here, and you'll find it very interesting. In the R, remember in the model, we don't have education, okay? In the model, we don't have education, but I am adding education here. And watch what is going to happen. We don't have education because we have assumed that education is constant. It's not changing. We did not include experience, but I'm still including experience here. Watch what R is going to realize. R is going to do something interesting here. We indicated that, what do you call it? Union is fixed. Oh, sorry, union is changing. Marriage is changing. Ethnicity is fixed. So watch, ethnicity. We have included it all. We have included it, but watch the sensibility, how sensible R is to realize that these are time constant variables. And R on its own will remove them for us. So the WF, please, the summary should be WFD to indicate the modeling process. So we're going to go into the R and then model the whole process there. Let's go to the R. And then this is our R. This is the first difference model. WFD PLM, okay, log of wage is explained by, that is a tilde sign. This tilde sign means that it is explained by. It is explained by education. Now remember, we shouldn't have included education, but we have. It's explained by experience, experience squared, union, marriage, ethnicity. We shouldn't have included ethnicity. And then of course, all the time dumps. And then we indicate that this is a panel model. And finally, we model the whole thing and add the summary. I'm going to run this command. Okay. It is a one-way individual first difference model. What happens? Let's run that. This is the results down there in the console. Watch what has happened. There is no education. Now, when you go up, you see the education was part of the modeling. Watch it. Education was part of the modeling. But then there is no education in the coefficient. Experience was part of the modeling. But watch, there is no experience in the coefficients. Because R understands that first difference model removes all variables that are constant. Isn't it interesting? It removes it. And even though experience is not there, experience square is there, just as we indicated. We indicated that union and marriage are changing, so they'll be there, they are there. But then we indicated that ethnicity is not changing, it's fixed, and so it will be removed. Truly, it has been removed. So the first difference model is good because those things are individual specific factors. They are the UI, the unobserved heterogeneity. The unobserved heterogeneity are factors that are changing. They are changing across individuals, but they are not changing across time. And that is why they were not brought in this first difference model. Now, so please guys, this is not something where, you know, like the previous one. This one, you get a different R square because this is a new model. It's not a pooled OLS. You will get a different R square in here. And you can see the R square and adjusted R square. We can later talk about them. You can see the F statistic. You can see. Now, this is another model. As to whether this model is good or is not good, we'll look at it later. But this is one way to remove the unobserved heterogeneity. Now, let's go to the actual results that we have. So in this actual results, you can see the whole thing. And I keep saying that once you understand what is happening, you can appreciate what is happening. Okay. You can appreciate whatever that is happening because you understand all that is happening. So this is a fixed first difference. Now, there's nothing different from this compared to the OLS, food OLS in terms of interpretation. The same way, when it has triple star, it is 0.1% and all of that. You can interpret the scores the way you want it. But when you use this, how do you know that your model is first difference and that is not food OLS? We'll look at the test to determine all of that. But for now, if the assumption is that these factors are not needed, if the assumption is that the unobserved specific factors should be removed, then first difference will be the way to go. We'll look at the merits and demerits of the first difference. We'll compare it to the limited dependent variable next time. We'll now estimate the fixed effect and the random effect model and compare all of them using the tidyverse table and the stargazer table. Okay. And then we'll now look at the link and the relationships with all of them. Okay. But for now, that is how you estimate the first difference model. Okay. We'll come and look at the limited dependent variable regression as well. But this is how you estimate the first difference model. Now, if you look at the R-square, you can surely see that there seems to be a problem with this model. Okay. It's not explaining much at all. It's not explaining much at all. But of course, why should it? Why should it? The time variables, the time dummies are not even significant here. Okay. So obviously that is the situation. Let me go to Grace, you have a question, and then we can address that. Yes, yes.
Please, beside the coefficients, it's written that one dropped because of singularities. Please, what does it mean?
Yes, that is the experience. So the singularities here, you know, the experience will be highly correlated with the experience square. When you go and check it, the experience will be highly correlated with the experience square. And so he's indicating that the experience square has been dropped, but actually it's not a big problem. It's not a big problem because it's part of the unobserved factors anyway. But when there's a high correlation between the two, and I did that later on to check the high correlation. So when there's a high correlation, that is when one will be dropped because of singularity, because it's kind of they are the same, but they are not. They are not. We have assumed one to be an unobserved heterogeneity. But remember, the experience is a number. The only thing is that that number is having having numbers that are not significantly different. Because you see, when you look at experience squared, when you square the thing, first of all, if the thing is 1 and you square 1, you will get 1. You know, you will get 1 in some of the cases. So obviously that is the similarity there. That is the singularity there. All right, so any question?